Let's take a look at part A1. So we've got 5 identical coins placed in the cells of a 3 by 3 grid. Here's one I made earlier. So that there is at most one coin in each cell and there is an odd number of coins in each row in each column. All right, so we can't put 2 in any one cell and we have to have an odd number. So if I put 1 here, and by the way, it says show 2 examples of how this could be done. All right, I've got 1 here. Now if I put 1 in a different column, then I'm going to have to put 1 here as well. So that would work, and I've got 3. And then I could put 1 here, but then I'd have 2 in this column, so I'm going to have to then put 1 there as well. The aim of this part is really to just get a feel for what's happening and see the restrictions. So there's no way that we could sort of put 1 here and then well, and then basically as soon as I put 1 there, and I put 1 in a different column, then maybe 1 there, then see, this is going to end up problematic because now I've got 2, and then, yeah, that's not going to work, that Z. So we're kind of almost got to start along a column or a row and then fill in after. Um, and what I'm trying to get at really is there's always going to be 1 column filled and 1 row filled. Must be, or must have. There's no way you can do anything otherwise. Let me just have a little look again to explain. Because if I try and sort of not fill a row, then I've got 2, so I'm going to have to fill it. And then if I put 1, say here, then I'm going to have to put 1 there for it to work, and I'm back with this same T. But the point is then we must have a row and a column filled. So in how many ways can this be done? Well, I've got 3 columns. This is part 2. So I could fill either the 3. And then I've got 3 rows, and I could fill either of the 3 there. And so I could fill column 1 with row 1, 2, or 3, or column 2 with 1, 2, or 3, and so on. It's going to be 3 times 3. It's going to be 9 ways. And I've illustrated 2 of them, and I've tried to explain how we get the other ones. So B, the related problem, but more complex problem. The numbers 1 to 9 are arranged in the cells of a 3 by 3 grid so that every row and every column now have an odd sum. Okay, let's look into this and how we can do it. Right, an odd sum. So the only way we're going to get an odd sum, we've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. So got 5 odd numbers and therefore 4 even. Now, the only way I'm going to get an odd sum is if I use 3 odd numbers in a row or column, or we could have 2 even numbers, so say 2, 4, and then an odd number. There's no way it's going to work otherwise. I can't have 3 even, I can't have 1 even and 2 odd, and that's all the different ways that we could do it. So yeah, we need to have this. So let's try and fill it out. So if I've got a 2, 4, 3, what could I do then? I'm going to have to maybe put another even one here and then an odd. And then I've already used a lot of the evens up, so I'm going to have to put in the other even one here, 8. So that could be 5, 7, and 9. So we can sort of see I'm putting my odd numbers along a row and along a column, and you can see the similarity with part A now. So let's try and fill another one and maybe use that as a guide. And there's no other way I could do it. So if I say I'm going to end up putting the odd numbers 1, 5, and 7 along a row, I can't avoid that. I can't just put two of them there because then it would, if I put an even number there, it would be even. So yeah, it's got to be, say, 1, 5, and 7. And then if I put an odd number anywhere else, say here, then I'm going to have to put the 9 there to make that one even, and then I'm going to have to fill these somehow, say 2, 4, 6, 8. But that's two ways of doing it, and along the way, I'm building up a bit of an idea of what to do next. So finally, we're asked to find the total number of ways that this can be done, and to write it as a product, not necessarily the whole amount. Okay, so basically we need exactly three odd numbers in one row and in one column. So odd, 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 odd. Aha, there are 9 ways to do this. And that was from B part 2. So actually, all we need to do now is work out how many different ways we can put in such a configuration into a specific yeah, say this one up here, I could go 1, 3, 5, 9, and 7. But um, actually, I can order these however I want. I've got 5 things that I'm ordering. So there's 5 ways of picking the top one, and then 4 ways, and then 3, then 2, then 1. It's actually 5 factorial ways of arranging the odds. In a particular configuration. And after that, I can put my evens in, say 2, 4, 6, 8. There's going to be 4 factorial ways of arranging them. And we're basically there. The total number of ways, or the total number of arrangements. Using the product rule of counting, it's going to be there's 9 ways to basically set up these configurations for the odd numbers. And then within each one, there are 5 factorial ways of arranging the odd numbers. And then we're left to arrange the even numbers in 4 factorial ways. And that is our answer. When I did it, I actually expanded it a little bit. I wrote it as 9 times 120 times 24. I just thought, the question kind of refers to that, but the mark scheme did allow for this here. So nice question, as always, like it looks quite complicated when you just look at this part, but this part really helps just set the scene, and it's an arrangements question at the heart of it, and a nice one at that. Well done.